As we go into topic 5 of chapter 2, equations of lines and linear models, a new equation is showing up here, which is called the point-slope form, in which if we have the slope and we have one point, substituting the 1 point there and the slope, we can end up with an equation in this form, which is the Slopeintercept form from the previous section. And then we said the equation of a vertical line was x equals a, and a horizontal line x equals b. And then we'll review parallel and perpendicular lines and do some of this other. So, what is the point-slope form of the linear equation in two variables? Well, we know that slope, this is the slope formula. If we multiply both sides by this, we end up with this formula. And if we put the y on this side and this on this side, we end up with the point-slope form. Now, again, what does it mean? Well, if we know the slope of our line and 1 point, and we'll do that, you can actually generate an equation of the line. So with that in mind, let's continue. And hopefully you've taken some notes so you have this down. Now here's a typical example that we'll have in which we have the point-slope form, y minus y sub 1 equals m times x minus x sub 1. And if you write this a few times, you get to memorize it. And there's our 1 point, and there's our slope. So basically what we're going to do is put our slope where the m is. This will become a negative 3. And then there's our x value. Now notice in the formula there is a negative. So as we put the x value in, we have to put a negative 4 there. And we'll see the reversal of the sign. And here this is just a 1. So this is what they've done. Watching the sign, this will become positive. We're going to clear parentheses. We're going to transpose this negative 1 to the other side, where it becomes a positive 1. And now we have it in slope-intercept form, where our slope is a negative 3, which is what we said we started with, and our y-intercept is a negative 11. Now, a modification of this is, suppose we don't have the slope, but we do have two ordered pairs. Well, with two ordered pairs, we can figure out the slope. So y sub 2 minus y sub 1 over x sub 2 minus, notice there's the double negative, which will make that positive. So this adds up to a negative 6 over 5. Now that we know our slope, we will put our slope into the equation, and we can actually choose either point. I see they have chosen this one. So the 2 goes where the y is, y sub 1. And the negative 3 goes where the x is. And again, we have the double negative, which we can make positive. We transport and get rid of our items here. Let me put it over here. Now another difference in this, they wanted our n equation to be in standard form. And here's where we are. So there's our slope. We've introduced our x and y, but we have a fraction. Now in standard form, they don't have fractions. So to get rid of our fractions, we're going to multiply every term by the lowest common denominator, keeping in mind this is just one term. So this is going to be a 6, multiply this by a 6, multiply that by a 6. And it looks like that was a 5, actually. That would have worked if that was the slope, but I had the wrong slope there. Copied it too fast. Okay, so our fraction is a negative 6/5. Again, this is just one term. We're going to multiply each term by now 5, which is the common denominator here. Now over here it just cancels out. So that's where we get 5y now. We have to multiply that, 10, equals, now here this is a negative 6, this becomes a negative 6x. This is a negative 6 plus 3, a negative 18. And we want to put it in standard form, so we're going to take this term, bring it over to this side as a positive 6x plus 5y. I'm going to bring my negative 10, becomes a positive 10, and now I have my equation in standard form. And you get to see me do it here. Okay, so again, a quick summary of this. They gave us 2 points. We had to determine the slope. Then we put it in the point slope form through careful substitution. Seeing that there was a fraction, we multiplied every term by the common denominator. That made it much easier to solve. And then we just transpose things until we have it in standard form. Now, what they're showing us here, every once in a while you'll run into this, where they give you a point and the slope, but notice that this point they're giving us is 0, b. It's in this form, which is the y-intercept. So when it's in this form, you could put it in the point slope form, or you could just immediately write it in slope-intercept form, because you already know what the y-intercept would be. So the slope is 1/2. We put the x there, and our y-intercept is plus 6. Now, if you wanted that in standard form, again, what you would do is get rid of the fraction by multiplying everything by the 2. You get 2y equals x plus 12. No fraction now. And then you take your x term, transpose that to the other side. That becomes a negative x plus 2y equals 12. And in some cases they don't want you to have a negative as your a term, a negative 1. They want this a term over here to be a positive. So you just multiply everything by a negative 1, and that just reverses all the signs. And that would be an example of what they're discussing here. When you have something that's in the form of a y-intercept here, 0, 6, 0, b. b is your y-intercept. Now, we've done this already, but a little review. Here is the slope-intercept form of the linear equation, where m is the slope and b is your y-intercept. Now, if you have an equation in standard form, how do you put it in slope-intercept form? Well, as we said, you solve for the y. transpose your x term, remember it changes its sign, divide everything by 5. So your slope now is your numerical coefficient of x, a negative 4/5, and your y-intercept is a negative 2. So it's sort of the reverse of what we've just done when we had it in this form to put it back in standard form. Now, what we're saying here is that we can generalize from example 3 that if this is your standard formula or your standard form of the equation in two variables, linear equation, we can solve for this y by transposing the ax to the other side, changes its sign, and then dividing everything by b. So we then solve for y. Now, what is a negative a over b? This is your slope. And what is c over b? This is your y-intercept. Now, we could use the slope-intercept form if we have 2 points, as we've mentioned before, to find the slope of this, and we get the slope is 3. Now, what we can do is to substitute. Now that we know what our slope is, we can put the 3 there, and we're going to take our 1 point of the 2 points we used, and our x value is a 1, our y value is a 1, and in this case we're just going to solve for b, which is another method rather than using the point-slope form. That would work. This is another method. So we get 1 equals 3 plus b. We transpose the 3. On this side it becomes a negative 3. Negative 3 and 1 gives me a negative 2 equals b. So we then rewrite the equation y equals, we know our slope is 3, x, we have to put the x in there, and our new b is negative 2. And that's what they're showing here. Okay? And again, you'll be practicing this. And extending that a little bit, we can find also by looking at a graph what the equation is. So let's set it up here. Y equals mx plus b. Well, what is b? B is our y-intercept, and that is a negative 1. And now all we need to do is find the slope. Well, we can make a little right triangle. And how many units are we going over? 1, 2, 3. This is a negative 3. And we're going up 1. So our ratio here is going to be a negative 1/3. And there's our equation that we've picked out from a graph. Wow. Again, we're doing lots of stuff. I like graphing. Now, a little review of our vertical line formula was x equals a. And we said a was the y-intercept. So it would be an equation, and keep in mind we often can write the ordered pair as a comma b for x comma y, where a would be our x-intercept and b is our y-intercept. So x equals a is just a vertical line going through, in this case, a -3. And y equals b, and in this case y equals -3, would be a horizontal line going through your y-intercept b. Now, they are mentioning this, and they are mentioning this, which is the equations we are using in this textbook. Other books, they sometimes change these letters, but this is the book that I actually probably learned it from. That's why we're using it. Keep in mind the slope of this was undefined, and the slope of a horizontal line is 0. Now, the more times you write this down, the better chance you have for mastering it. We're going to now take a look at slopes that would be parallel, and then slopes that would be perpendicular to each other. And there are formulas and background for this that we'll get on the next page. And I'll just give you a little bit of a summary here that you can take some notes on. So a good summary of what's going on here: if the slope of one line is equal to the slope of another line, but the y-intercepts do not equal, then the line will be parallel. This is for line, and this is the symbol for parallel. Now, the other case is if you take the slope of one, multiply it by the slope of the other, and as you multiply it, the product is a -1, such as if the slope of one was 1/2, and the other was a -2, and we could put it over 1. So you see they are reciprocals, but one is negative. The results give you a -1. Then these lines are perpendicular, an upside down capital T. Okay? Now keep in mind, if you had the x and y axis, that they're perpendicular. This one has 0 slope. This one has undefined slope. Okay. Now here they want you to find the slope, intercept, and standard form of the line that passes through this point and satisfies the given conditions. Well, these equations are the same, but we want a line first that's parallel and goes through that point, and one that is perpendicular and goes through that point. So again, what do you do? Well, the first thing you have to do is find the slope of this line. So we're going to solve for y. 5y equals a -2x. Just transpose that, and then plus 4. So we're going to divide everything by 5 now, and we get y equals a -2/5 x plus 4/5. Well, our slope then becomes, or is, a -2/5. So if we want a line that is parallel to this, it's going to be a line that has this slope, but has this as a point. So we know what our y is. Let's put it in this form here. Y equals mx plus b. So our slope now we know is a -2/5. Our x is going to be a 3 plus b here, and our y is going to be a 3. I'm sorry, y is going to be a 5. Yes, got carried away there. Now, again, since we want this in standard form as well, a good idea is get rid of the 5. So we multiply every term by 5. And now on this side there are 3 terms. So this is 25. Here my 5's cancel out. But I have a negative 2. This is going to be a negative 6 plus 5b. Okay, so now we're going to transpose this. This becomes a 31 equals 5b. So what is our b value? Well, we're going to divide both sides by 5, and we get b is 31 fifths. So going back to this equation, we have y equals a negative 2 fifths x plus 31 fifths. And again, we want to get rid of the fractions. That would be in slope-intercept form. But to get rid of the fractions now, we multiply everything by 5 again. And we get 5y equals, this cancels out here, negative 2x, this cancels out, plus 31. And now we're going to transpose this to the other side, and we get 2x plus 5y equals 31. So we have it in slope-intercept form, and we have it in standard form. Now, this would be a line that is parallel to this one. Notice the only difference is the new value over here for the 4 is a 31. So we realize those lines are parallel. But how about if they're going to be perpendicular? Well, we know over here that our slope is a negative 2 fifths. So what will be the slope of a line that's perpendicular to this? Well, remember, it's going to have the opposite sign reciprocal. So the new slope will be a positive 5/2. And we're going to do the same thing as we've just done. And I'm pretty sure it's here in our textbook. So let's bring it up so we can see what they're doing too. So there's our first one. We did that one. And now we have found in a sense, the negative reciprocal of the other, which becomes positive. And we could choose either point. They're using the point-slope form. They're going to multiply everything by 2. That's what I would do to get rid of it. But eventually they get this. I see they're just bringing this over to the other side, which is okay, another way to do it. And then once they get it in that form, they move the 5x to the other side. But again, it goes over there as a negative, but then they're going to multiply everything by a -1 to change the signs. All right, spend a little time on this. The tape's getting a little long now. I don't want to do too much, but again, it shows it very nicely here. They're leaving out a little step here. Let me show you this step. This step here, where they're taking the 5 from this side, bringing it over to the other side, it becomes a positive 5. But in order to be able to deal with it here, we have to have it in common denominator. So this will become a positive 10 over 2. So this -5, as we transpose it, becomes a positive 5. And we're going to write an equivalent form with a fraction that will be able to be a common denominator. So this is equal to 10 over 2. We want to get that 5 over 1 to become something with a denominator of 2. And that's where I get the 10 over 2. So now when you do it, you go 5, y equals 5 halves x minus 5 halves. So there it is now in slope intercept. And then we're going to multiply everything by 2 to get rid of our fractions, and we get this. And then we just transpose that. On this side it becomes a negative, but we want to have it in standard form where our first term is positive. So we multiply each term by a negative and it reverses the signs. Okay, lots of stuff going on. So they show you some things using a calculator up here, where if you see these have the same slope but different y-intercepts, and those lines of course would be parallel. Now looking at equations in slope-intercept form, notice that if you multiply this slope by this slope you get a negative 1. So these lines, one being the negative reciprocal of the other, are perpendicular to each other, as we mentioned in our formula. And there they're showing it. Here, because of the way this is set up, they don't look quite perpendicular. Here they had to change the window size, so now they do look perpendicular. Okay. So once again, a review of the formulas we've been using: slope-intercept, point-slope form, standard form, horizontal line, vertical line. Now interestingly, we did all of this in Math 1103. So if you're one of those folks that have moved up, you'll see this is not unfamiliar material to you. Okay, we're going to take a look now at modeling data and then finding an equation of a line that models data. So here we have years and cost. So I don't know if you can see, this is time and then this is amount. We're going to plot the time on the x-axis, and we're going to start really high up, so we put that ziggly line there and start with 5,000. And notice our data is pretty much in a straight line. So this is linear. So with that, we can actually find an equation that models this. How do we do that? Well, if we take our first year, which is 2005, and make this the 0 year, I guess I can write that in there. This will be the 0 year. Notice we have 0, comma, b, which is our y-intercept, which is right there. So all we need to do then is to find the slope of this line by taking two sets of data and putting it into either the slope-intercept form or the point-slope form. And then they want us to predict from this what something would cost in 2012. Well, if this is 2005, how many years after? 7. So we have 6, 7. We're looking for something out here. And once we get our formula, y equals mx plus b, we know our b is this, and we just have to find the slope. And then over here, we're going to put a 7 for our years. So when we find our slope, we multiply it by 7, and then we add our b value to it, and that will be 2012 down here. Okay, I'm sure the book has it all worked out for us. We gave you the strategy. All right, there's our slope. And there's our y-intercept. So we just plug a 7 there, multiply this, and that gives us what our answer would be. And again, MATLAB's a little challenging when they ask you to round off. So be very careful about that. I found that if I put the round off wrong by a little bit, or I add an extra decimal place, they count it wrong. Now, I'm pretty sure your teacher would give you credit for that on your test, because you did all this other work. In fact, much of this work, I'd give you most of the credit. I would just take off a little tiny bit if you didn't round off correctly. Okay. Let's go on and see. I think we're getting close to the end here. Again, some of this you could put into a graphing calculator and get what they call a linear regression. And we're not doing that, though, but I don't know. It depends on what your teacher will ask you to do. And that brings us to our exercise. Now, keep in mind, in your online textbook, there are lots of other little exercises that you could look at to get some ideas. But I think with your practice in Quiz Me, that'll be enough as you prepare for your test.